Today, we are going to examine the wiring connections of different types of single-phase motors. The first type. This is a single-phase motor with two capacitors. One capacitor is the starting capacitor, and the other one is the run capacitor. In these motors, there is a centrifugal switch that disconnects the starting capacitor from the circuit after the motor reaches full speed. In the image, you can see the centrifugal switch. This switch is located at the back of the motor. It has a normally closed contact. When the motor reaches approximately 75% of its rated speed, the contact opens, and the starting capacitor is disconnected from the circuit. Now, let's see how this motor is wired. On the motor terminal board, 4 wires come out from the motor. These 4 wires are connected to 4 terminals on the terminal board. They are labeled as U1 and U2 for the main winding, and Z1 and Z2 for the auxiliary or starting winding. For the connection, we connect the phase wire to U1. Then, one terminal of the starting capacitor and one terminal of the run capacitor are also connected to U1. The other terminal of the run capacitor is connected to Z1. The other terminal of the starting capacitor is connected first to the normally closed contact of the centrifugal switch. Then, the output of the centrifugal switch is connected to Z1. The neutral wire from the supply is connected to U2. Then, we connect a jumper wire from U2 to Z2. And with this simple connection, we can correctly wire a single-phase motor with both a starting capacitor and a run capacitor. You may sometimes open the terminal box of a single-phase motor, and find 6 terminals. Instead of 4. Don't worry. This motor works exactly the same as the standard 4-terminal version. The only difference is that the manufacturer has brought out the 2 terminals of the normally closed centrifugal switch into the terminal box. These 2 terminals are labeled V1 and V2. In other words, instead of wiring the centrifugal switch internally, its 2 connections are now available directly on the terminal block. This makes the switch much easier to access for testing or wiring. So, the motor itself has not changed. The operating principle is exactly the same. The only difference is that you now have direct access to the normally closed contact of the centrifugal switch through terminals V1 and V2. The second type is a capacitor start single-phase motor. If you come across a single-phase motor with only one capacitor and a centrifugal switch mounted at the rear of the motor, you can immediately identify it as a capacitor start motor. In this type of motor, the capacitor must not remain permanently connected to the circuit. It is used only during starting. Now let's wire it. Connect the phase live conductor to U1. Then connect one terminal of the capacitor to U1. Next, connect the other terminal of the capacitor to the normally closed contact of the centrifugal switch. Then connect the output of the centrifugal switch to Z1. Finally, connect the neutral conductor to U2. Then install a jumper wire between U2 and Z2. One important point: capacitors do not have an input or an output. So, it doesn't matter which capacitor terminal you connect first. If you reverse the 2 capacitor wires, the motor will operate exactly the same. The third type is a permanent capacitor single-phase motor. If there is no centrifugal switch behind the cooling fan, and the motor has only one capacitor, you can identify it as a permanent capacitor motor. This type of motor has the simplest wiring of all three types. First, connect the phase, live, conductor, to U1. Then connect one terminal of the capacitor to U1. Connect the other terminal of the capacitor directly to Z1. Now connect the neutral conductor to U2. Then install a jumper wire between U2 and Z2. And that's it. We've now covered the wiring diagrams for all three common types of single-phase motors. Once you identify the type of motor, you can wire it quickly and correctly. Friends, sometimes you may open a single-phase motor and notice that 5 wires are connected to the terminal board. On this terminal board, manufacturers usually provide 2 Z1 terminals. The reason is to allow us to easily change the motor rotation direction directly from the terminal board. The manufacturer has already installed a jumper between the 2 Z1 terminals inside the motor. So, we only need to change the position of the links, terminal bridges, to reverse the direction of rotation. This simple arrangement makes the wiring easier and allows quick direction changes without opening the motor or changing the internal connections. Now, you may come across some single-phase motors where, instead of 4 wires, only 3 wires come out of the motor. So, how should we connect these motors? As I mentioned before, there are 3 wires coming out of the motor. One of these wires is the common wire. This means one end of the main winding is internally connected to one end of the auxiliary winding, and this connection point is brought out as a single wire from the motor. The other 2 wires are one end of the main winding and one end of the auxiliary winding. Now the question is, how can we identify which wire belongs to the main winding, which one belongs to the auxiliary winding, and which one is the common wire? It can be easily determined using an ohm meter. We need to measure the resistance between the wires, one combination at a time. The 2 wires that show the highest resistance value are the ends of the main winding and the auxiliary winding. The remaining wire is the common connection point. By identifying these 3 terminals correctly, we can safely perform the proper connection of the single-phase motor. For the final connection, we connect the capacitor between the 2 ends of the main and auxiliary windings. Then, we connect the single-phase supply to one side of the capacitor. Finally, we connect the neutral wire to the common wire of the motor. With this connection completed, the motor will start running, and our fan will begin to rotate. This is the basic wiring method for a single-phase capacitor-run motor with 3 external wires. Now, if we want to reverse the rotation direction of the fan, we can simply move the phase connection to the other side of the capacitor. By changing the phase connection point in this way, the magnetic field direction changes, and the motor will start rotating in the opposite direction. This is a simple method used in many single-phase capacitor-run motors to change the rotation direction without changing the internal motor wiring. Have you ever noticed that most single-phase motor nameplates don't show the capacitor value? So, what should you do if the capacitor label is missing or the capacitor has exploded? Let's find out. The first step is to calculate the run capacitor using the motor current. The motor current is always listed on the nameplate. Let's use a real example. Suppose we have a single-phase motor with these specifications. Current, 6 amps. Power factor, 0.75. Now let's calculate the required run capacitor. We use this formula. In this example, the supply voltage is 220 volts. If your country uses 110 volts, simply replace the voltage in the formula with 110. Now substitute the values. We multiply 1950 by 6. Then divide the result by 220 multiplied by 0.75. The answer is approximately 70 microfarads. That means this motor requires a 70 microfarad run capacitor with a 450 volt AC rating. Now let's calculate the starting capacitor. The starting capacitor is typically 3 times larger than the run capacitor. So we simply calculate 3 multiplied by 70 equals 210. Therefore, the required starting capacitor is approximately 210 microfarads. Remember, this calculation gives you a reliable starting point whenever the original capacitor markings are missing or unreadable. Save this formula. You'll use it many times when repairing single-phase motors.